Okay, welcome to the lecture for CSE 1030 for Wednesday, April 16th. Today we're going to talk a little bit about using the time functions that are in time.h to do various things in our program. We're going to use an ACM reference to do that, so we'll look at several of the functions and some example code. So in time.h, which is the header file that we would use to use these various time functions, there are a number of things defined. There's some macros which define null, as well as a value for clocks per second, which is CPU dependent. Some variables that are all type defs. So there's size t, clock t, and then a structure as well. And then there are a number of functions that are listed here, and we'll look at each one of them and what they do. So null is just a definition for null. Clocks per second defines the number of clock ticks per second for a particular processor. Size t is an unsigned integer. Clock t is a type suitable for storing the processor time. It's usually a long or an unsigned long. And then time t is a type suitable for storing the calendar time, which we'll see what that looks like in a minute. And then the structure tm is a structure like we've been talking about lately. And it includes a bunch of information, all defined here, that are all integers, that are basically the components of a timestamp. So there's seconds, minutes, hours, day of the month, month since January, year since 1900, day of the week, so Sunday to Saturday, day since January 1st of that year, so the day of the year, if you will, and then also an indicator of whether we're currently observing daylight savings time or not. So those are all things that we'll use in a little bit. The first function is called ASCII time or ASC time, and the way that one works is we pass it in a pointer to one of those structures, which it's going to fill up. At the same time, it also returns a string. So actually, I take that back. We have to get the structure first of all, and then we can call this and get the string. And the string that it's going to return is a standard format. We have other ways that we can build ones of our own. The format is shown here. It starts out with the day of the week, so it'd be Sunday, Monday, Tuesday, etc. The month of the year, and then the day of the month, and then the hours, minutes, and seconds, and then the year. And that's the standard format. So here's a real simple example program of how that works. Include time.h along with our normal stdio. Create a time t value, call time, which returns a time t value, which has that structure in it. And then we pass that timer value to a function called local time, which generates one of those structures. And then, so timer is giving us that seconds since January 1st, 1970. Pass that to local time, which gets us a structure based on whatever the local time zone of the machine we're running the program on. Not necessarily where you're sitting physically. If you're running on a machine that's in a different time zone, if it's in Minneapolis, for example, or if it's in California, it's going to be a different time. And then ASCII time will then turn that into a string, which we can pass to printf. So notice there's two function calls embedded in here. We're passing the thing we got back from time to local time, which in turn is being passed to ASCII time. And we could have done those in separate steps as well. So the end result of this then is I'll get, based on whatever the current date and time are, I'll get a string that's in the format listed up here. So it might say something like, if it were today, it would say Wednesday, April 17th, and whatever the hour is that you're listening to this, and then the year 2014. Okay, the next function is called clock, and what this does is it returns the processor clock time used since the beginning of an implementation-defined era, and then if we take that value and divide it by clocks per second, it'll result in the number of seconds. If for some reason the value is invalid, then we'll get a -1. So let's take a look at usage of this one. So defined a couple of clock t values that we can use. Called clock, stored that into ticks1, set ticks2 equal to ticks1, and then basically while that value is less than 1, we keep going. So until there's been another second, until a second has passed, this loop is going to keep going because there's several clock ticks per second. And this will tell me how many ticks it took to wait 1 second, for example. So you see here what we can do is we can use these. We can call clock, then do some stuff and call clock again and store two different values. and that'll tell us, when scaled by the clocks per second, how many clock ticks initially, and then if we scale it, how many seconds passed between calling clock the first time and the second time. So this is one way that we can time how long a particular part of a program, or an entire program almost, takes in seconds or in clock ticks, depending on whether we scale it or not. And we'll see some other ways we can do timing here in a minute. The third function is ctime. You'll notice we're just going through them in alphabetical order at this point. Third function is called ctime. What ctime does is it returns a character string, the local time, based on the argument timer. So first of all, we have to get a timer value. So typically, just like we did with the ASCII time, we get a similar kind of a timestamp. But in this case, we can do it directly off the timer value instead of having to pass it through local time first, which is what we had to do with ASCII time. Okay, so it'll give us a similar kind of format as what we got before, and it returns that as a pointer to a string. Diff time takes two time t values and calculates the difference between them in seconds. So I can use that with anything that returns a time t type of value to determine the difference, and we'll see another usage of that in a minute. GM time works similar to the local time function. We give it a timer value, and it'll convert that to a time structure that we can then use to pass to ASCII time or something else. But it does it in Greenwich Mean Time or Coordinated Universal Time as opposed to the local time zone. So if we want something in and be able to compare times at different locales, for example, based on some standard point of reference, we can use that. We already saw use of local time. Local time takes a timer value that we get from time and converts it into one of those structures that then we can pull the bits and pieces out of, or use ASCII time to convert it into a string. So there's an example of using that, again, with ASCII time to get a string. Now, make time is an interesting one. Let's say you want to create your own timestamp that's for a particular time and date that's not right now, or not something you're going to get from the system clock. So you, for example, wanted to put in a time structure for the start of the War of 1812, or whatever it might be. And then you want to be able to compare that to a timestamp from the computer right now, so you can figure out how long it's been since the War of 1812, for example. So I can do that if I know what those dates and times are using MK time. So what I do is I create one of those structures. You can see it down here in the example code. So we create an instance of a struct TM type. In this case, it's called time struct. And we fill it up. So, for example, here we're setting the year equal to 2001 minus 1900. 1900 is, remember, the epoch time that it said that it was based on. So because this year value is a difference of years, or it's a number of years. It's not a physical year. So it's the number of years since 1900. So if I wanted to create a timestamp of something in 2001, as the commenter says we're trying to do, then 2001 minus 1900 would be the appropriate value for that. And then I could set the month and the day. So this would be January 1st, and then hours, minutes, and seconds of 000, so midnight, and then not during daylight savings time. Set all that in a structure, and then call make time, and it'll turn that structure into a timestamp. And of course, if I get some kind of an error, then I can print a message, and then I could print it out this way. But the interesting thing is you could also use that then as a timestamp that you could do, for example, diff with, and say, okay, what is it now? So how many days has it been, for example, since January 1st, 2001? Okay, so we could use it to create a particular timestamp and then use that to compare to timestamps we take directly from the clock or other timestamps. So this could be used with, for example, file timestamps and stuff. STRF time is interesting. What this does is it lets us take the values out of that time structure and format it in a way that we want it formatted. Whereas ASCII time gave us a fixed format. We didn't have any control over it. It just was a particular way. STRF time lets us take that information and put it in a particular format. So notice it has quite a few parameters. The first parameter is a string you're going to write your newly formatted date and timestamp into. So that needs to be a character array buffer of like 100 characters or something like that that you can write into that you've declared. Size t, this max size, is the size of that character array that you created. And then format's going to be a format string, kind of like with printf or sprintf or something like that. And then this tm thing over here is the current time structure. So you've already called time, you've already converted it into a structure with like local time, but now we want to change the format of how it's going to be put into a string so we can, for example, print it out to the user. And so 3 of the parameters are pretty clear. The format one is a format string, just like with printf, except it uses different format specifiers. Instead of the %ds and %i's and all those that we've been using, there's some different formats, but it's still a string in quotes. So all the conversion characters start with a % sign, but they're listed here. So if you want, for example, A represents the weekday name. The lowercase a is an abbreviated one like WED for Wednesday versus the full week name Wednesday, etc. And then B is for the month, and we can get an abbreviated month like JAN or full month January. %C would just use an appropriate date and time representation depending on how big my string is. %D for day of the month, there's only one way to do that. And then we've got hours, minutes, and seconds. So we've got, first of all, hours of the day. Capital H is in sort of 24-hour clock time. Capital I would be in 12-hour clock time, so we'll have an AM, PM. %J for day of the year, so basically 1 to 366 if it's a leap year, 1 to 365 if it's not. The month of the year, so the month is a number instead of as a name. That's a lowercase m. The minute of the hour, that's a capital M. A lowercase p is an AM, PM designator, so whatever's appropriate it'll put there. The number of seconds for the minute. The week number of the year, so we could do a particular, so there's 52 or 53 weeks in the year. The weekday, where Sunday is represented by a 0, so it'll actually write out the weekday. Capital W would be the week number of the year, where Monday is the first day of the week. We can also use a %X, which would do an appropriate date and time representation, sort of a standard one. The year without the century, so the 2-digit year, or a capital Y year with the century, so a 4-digit year. The Z, which would print out the time zone abbreviation, so like CST or CDT if it's daylight savings time. And of course, if you just want a % sign for some reason, you do a double %. So we can format a specific time and date stamp string using that. Okay, then there's the time function, which is what gives us the basic timer, that epoch timer or that era timer that we can then use to call pass to the other functions like local time or GM time. So this is kind of the one that starts it all. This gets us that number of seconds since January 1st, 1970, and then from there we can convert it into a local time or GMT time, and then from that we can create the structures, and then from that we can create formatted strings or do computations and things like that with it. So those are the basic time functions that we have available to us, and we've seen some examples of using those. So you may find these useful in functions, certainly to just print out time and date information, for example, to label your output, whatever that may be. You may also find it useful for timing, so we can use it to time how long a particular part of our code takes. So for example, if we wanted to look at some of the searching and sorting algorithms that we've been talking about, I wanted to create an implementation of those and then be able to time how long it actually took to do it for a particular problem with a particular, say, array size or something like that, and then maybe time several different ones so we could see which ones actually operate the fastest, not based on just that theoretical what's their order, n squared, log n, all that, but actually get some physical times on a particular machine with a particular data set. Then we could use these functions to do those kinds of things as well. And we'll try to look at some of those, some examples of doing some of those kind of things at a later date, and perhaps on Friday. So that's what I wanted to cover today, a fairly short lecture. I'd like you to look in your book and see if you can find examples of using the time function. You're certainly welcome to look online and see if you can find other examples of using the time functions and see what you can do and maybe play with it. Maybe write some code, or on the homework that you're working on, try using the time functions, not necessarily to turn in, but just to see if you can time some of the things that are going on. Or maybe use it in your homework to add a timestamp to your output. Certainly you won't get counted off for adding something extra in there. Or you can always take that code back out before you turn in your assignment. But try using these a little bit and see what you can do with them. I'll see you on Friday, and I hope you're having a good day, and we'll talk to you soon. Bye-bye.